Hi, it's Terry Dennery of the MathWorks. So in this video, we're going to explain how did we get here, right? And so in the previous video, we showed this really great tool, or at least we showed a really great mechanical model that really represents things the way that we represent them in Simulink with Simscape Multibody. And we showed that we could just cleanly, directly import this and get what we want with regard to mechanics represented inside Simulink. So it's a great utility, and I just want to kind of show in this video that it works really well from a creation point of view too, that building this mechanical model is very straightforward. We're going to do it pretty quickly. So anyways, let's go ahead and stop. Let's reset. Actually, let's go ahead and delete this and let's just work from scratch. So we're going to do a new model. And that, let's see. Oops, that's not where I want to be. I want to be here. All right, so I created a new, you'll see I did a practice. So let's go ahead and delete this even. I think I can delete it here. Yes, I can. So we're inside MATLAB. I just deleted that, but we're going to create a new one and put it in this directory, and we'll see as we go through this, or at least maybe in the next video when we bring it in. Well, whatever. Let's go ahead and save it there, though. So save. We're in that directory, and we'll call it Terry 4bar. Right, and you'll see it show up as I hit the save button right there. So that's MATLAB. Yeah, there it is. Okay, so it's blank right now, and it's 4-bar linkage, but that really means there are 3 moving bars, and that the 4th bar, of course, is the ground. And so I'm going to make 3 of these, but let's go ahead and do one first, and we'll put in this special kind of geometry of 0.01 on the x direction, 0.02. Basically, you could think of this as length, width, and height, the 3 parameters that define the extruded rectangle, and we'll make it 0.1 on its length. Now click on Apply. Under Appearance, I'll replace the default name of Body 1 to A, and let's click Apply and Close. Right, and I'm going to go ahead and actually let's do a couple things. So let's really zoom in on this. Maybe do a bit of a rotation so you can see that there are 2 coordinate frames. Now most of this blue one, what's associated with that body, is covered up by the body. So I'm going to look at it in a transparent view, and we'll see it's an XYZ coordinate system. Its origin is at the center of mass. And the reason I want to show it now is I'm going to position this, and we'll see that it's really positioning within this black frame. And it's essentially taking the origin of this coordinate frame and locating it in the XYZ of the world. And so I'm going to put in 0 for X. It's off screen now, but I know that, yeah, if I start putting in zeros, eventually I'll get it exactly coincident with the world reference frame. That's not exactly what I want. I want the bottom surface to be in that, I'll call that, what is that, the XY plane. And so that means I need to boost the whole thing up, not 0.5, but 0.05. All right, and so that's the position I want. All right, and I'll hit run, and you'll see it falls. You know, it's an initial position, but that's where I want things started. All right, and so I'm going to hit this magnifying glass. I'm going to zoom out a little bit, and I'm going to do a couple of things. I'm going to mark kind of, these are going to essentially be how this assembly connects into other assemblies. Right. And so I'm going to put 2 frames on it. Now both frames are a little bit small, and so instead of using the defaults for kind of scaling things, I'm going to just go ahead and hit apply, and we'll see that they're a little bit bigger now. Okay. Now the next thing I want to do is I want to put them at the ends, right? And I'll explain what I mean by that. But I'm going to take both of them in a selected state, right mouse click, get to properties where we assign the positioning of these frames. And we're going to see that we're going to position them now within the reference frame of that body. Okay, so in terms of this blue XYZ. Okay, and this is exactly how we do it inside Simscape Multibody as well. All right, and so it's going to be 0 in X, 0 in Y. Okay, and then I'm going to make it 0.05. It's going to move them both to that far end. Yeah, so we're going to see those 2 frames right there on my list. I'm going to select now just on the single one, and I'm going to make that minus, right? And so now we'll see the 2 of them both clearly, and that they're both kind of at that at the ends of the bar, right? And I'll adjust my view so we can kind of see that. So that's the way it is right now. And you notice when I hit run, the whole thing falls due to gravity. But what I now have is a nicely marked position. And if I select that frame, it knows it's connected to A. And if I bring up this create joint um, utility, I can say, well, make a revolute joint at that location marked by that coordinate frame. And so when I hit run now, we see it no longer falls due to gravity. You know, it's living in this, kind of unreal simulated world where it's okay with the idea that that's perfect orientation. So even though we know that's unstable, that's the inverted pendulum, because of the perfection of placement and orientation, we're not going to see it fall yet. Okay, but let's start adding some of the other. This is something I practice it to do a little bit better than what I'm going to do right now. So now I'm going to do something that is going to introduce you a little bit more to the tool and what just took place. But here's that joint that we just created, the green cylinder, right? And for right now, I'm going to call it GA, because what that represents is a ground, and we're going to see it in the name of the frame that was created for us. The frame, the coordinate 6 that is on the ground, is going to connect through this joint to the body A as marked by the location of chord 5 on A. Okay, so anyways, what I wanted to get at though is that we need 2 more of these, right? It's a 4-bar linkage with 3 moving bodies, and they're all going to have kind of the general cross section of what we did for A. And so what I'm going to do now, a little bit awkwardly, is select A and the 2 chords attached to it. We see in this selected thing here that we kind of got what we want, but we do not want the joint itself. So we have A and the 2 chord frames selected. Sorry, I had to go into so much detail. I could have. All right. Okay, and with that, I do not have what I intended to do. So let me undo every bit of that. Okay, so let's try that one more time. So A is selected. That chord is selected. And the chord on there is selected. Maybe I'll even hide this. This is probably the way I should have done it too, right? I can deselect everything. Only the stuff that's appearing that's not hidden, that's the stuff that can be selected through the viewing area. And so now I'll go Control C and I'll hit V, and I'll have 2 more copies of that. All right. Well, the second copy, or the second position one, I'm going to just rename it B. And then this third one, I'm going to rename it C. Okay. And now I'm going to kind of hide all the C stuff too. And we'll bring that back in a second. All right. And so what I want to do with this O now, and I think I'll put shading back on, is let's make this bigger. All right. So we're going to keep 0.01 and 0.02 for the X and Y dimensions, but let's make it twice as long, 0.2. Right. I think that's really kind of cool that it knows that the frames know they're on the end, and therefore they're going to move as the whole thing moves. And that's very convenient, actually. All right, now we'll kind of get into, we talked a fair bit about positioning in terms of XYZ placement, and now we're going to talk about rotation, right? And it's kind of a simple orientation change. We're going to simply rotate the whole thing 90 degrees. Click on apply, you'll see that change was made, right? And just for your information, these are Euler angles. The sequence by default is rotation X first, then Y, then Z. So if you know what Euler's angles are, that might be useful information for you, right? And let's just kind of look at it from this view. You do a slight rotation just so you can see they're not completely overlapping. And I'm going to select these two guys right here. And so this time creating a joint, there's a little bit more going on, right? The previous joint was made based on the location 1 coordinate frame, right? Now what's happening this time is that it's going to take the chord right here, and it's going to move it to this one, and it's going to keep it fixed to that body, so the whole body will move as we do it. And that's what all this information is really about. But let's just go ahead and say revolute joint create. All right. And now when we hit run, something more interesting happens, and we'll see kind of the movement that's ultimately driven by gravity and those gravitational moments. So anyways, that's kind of neat. All right. And so we're actually quite close to kind of having the whole thing done. And so we're going to bring C back, show it. And let's go into the length here of the box. And this one we will make 2.5. All right, close. And we're going to do pretty much the same thing. So that frame and this frame, and we click on join, another revolute joint. Let's click create. Zoom out a little bit. Let's use the pan tool, move it up too. All right, and we'll hit run. And that's our movement now. All right. And so we'll finish kind of creating a joint the same way we did the first time with just 1 chord selected. And you'll see that the defaults, again, work pretty nicely for us in that it's going to say, oh, only 1 chord selected. I see it's on body C. All right. And that I'm going to create a new chord, and I'm going to attach it to the background. Right. And so we'll make that a revolute joint as well. All right, and again, we're in an equilibrium, albeit an unstable equilibrium, but the perfectionist simulation will allow that to kind of hold its position. And I think that this kind of, again, gets us to kind of this place where, well, you know, we want to bring into Simulink, and we do want to move it, and we're going to move it according to kind of a torque identified by a control, right? And so I'm going to turn this guy into a motor. Now, so far, that's just its name as motor, right? And I'm going to hide that, and I'm going to zoom in on it even. And so we'll see that, you know, the idea of a revolute joint is there's a cylindrical shape associated with it. And to turn it into a motor, we click on this, revolute motor. And if you look real close, we'll zoom in real close, and you'll see kind of that cylinder's there, but also add a little platform. Okay. Anyways, I love looking at these icons, so please, hopefully I'm not overdoing it. Okay, and let's show everything. And I'm gonna hit save, and basically I think we're where I wanted to get to, right? So this is really where we started the previous video, and it's from here we saw that we could bring in mechanics into Simulink that are much richer than what we've been working with and really do something pretty interesting because of it. So anyways, thank you.